Hello everybody, thank you for joining me today. I am Francisco Orchard from EpiConcept, and I'm going to talk to you about Pandem-Source, which is a tool developed by the Pandem-2 Consortium, an H2020 project dedicated to pandemic preparedness and response. So, Pandem-Source is a tool for routinely collecting heterogeneous surveillance data into a coherent database. And today I'm going to explain you Pandem-Source based on these 6 principles. Well, its objective, as I said, is routinely collecting heterogeneous surveillance data into a coherent database, which means that we're going to have data coming from traditional and non-traditional surveillance sources. We're going to collect systematically information like reported cases, hospitalization, vaccination, which is data usually reported by public health agencies, national institutions, but other kind of initiatives like participatory surveillance or mass media, social media, flights or weather. Any information that could be potentially useful in the situation of a pandemic could be imported into Pandem-Source. It is designed for that. Its target audience are first responders, public health agencies, international organizations such as ECDC or WHO. Pandem-Source is open and local. It's open source. It's a Python package you can download and install in your machine. It runs locally and integrates with R or Docker for natural language processing model. It's flexible. It can import data from websites, GitHub repositories, feeds, or local files in many formats as JSON, XML, CSV, or Excel. And users can add new sources and variables without any change in the code. It focuses on data quality. It has a system for data standardization, error control, and also source traceability, which means that information like owner, data quality is displayed on reports. And finally, comparability. Pandem-Source will compute comparable epidemiological indicators between data sources. And now I'm going to show you the tool. When you arrive to what I'm showing you here is a Shiny app that is the front end for Pandem-Source. And as you can see in the homepage, what you will see is a list of data sources with its progress. So here we can see information like COVID-19 Data Hub, which is a COVID-19 data aggregator from different national agencies at fine-grained level. We have ECDC data, Eurostats, ECD-10, which is a list of diseases for standardization, InfluenzaNet, which is a participatory surveillance program, Medicis and Twitter, which is data from Medicis is a mass media aggregator, and Twitter, as you know, is a social media, and also information that was provided manually by our partners from Pandem-2, RIBM, RKI, and THL. So Pandem-Source is continuously monitoring any of these sources, and it is scheduled to fetch new data from them on different schedules. By example, some of them can be daily, like COVID-19 Data Hub. We're going to check each night at 2 a.m. for updates. ECDC Atlas or ECDC COVID have similar configuration, but we can have also things like Medicis or Twitter, which have much reduced time scale, like 5 minutes or 30 minutes. And so if I click into a particular source, I can see the different jobs that were imported to see if everything has been going fine, the last integration information, And also I have information, as I can see here, the number of issues that were identified in last integration. By example, here in ECDC Atlas, if I click, I can see that there is a code that was not recognized in Pandem-Source referentials, and so this data was not imported. And so a user which is responsible for managing an instance of Pandem-Source could make a decision of fixing the source, adding this new code to the referential, and then relaunch the integration. This is about the progress, so you can monitor here if your data is updated and how updated it is. Then we have a list of data sources. By example here, well, we have here all of the different data sources configured, and we can see, by example, InfluenzaNet, and we have all these definitions which are coming from a text file, which is a source definition file, and here we are just displaying it, showing information about the name of the source, a description, and important information as the data quality, in this case is a cohort, the update frequency, the source, in this case is an URL, the format of the files, and the mapping between the variables in the file and the Pandem-Source variables. We also have here a data dictionary for all of the variables that are present into Pandem-Source. So we could filter, let's say, and see all of the variables here that are declared in Pandem-Source. This file is managed by this list is managed by an Excel file, and a user could add new variables or remove variables as they want to. One of the important things we learned during Pandem-2 project is that some users told us that during the beginning of COVID-19, everybody went back to Excel because the existing reporting system were not flexible enough to respond to the new challenges of data reporting that was necessary to engage with code. And that's why we made Pandem-Source flexible, so a user could just add new variables by adding a line in an Excel file, and these are our different variables. And as I said, some variables have a formula. This also can be changed by the user. These are simple R scripts that apply a formula to the data, and in this case it's active cases that is calling a function called active cases, receiving as a parameter reporting date, confirmed cases, and pathogen code, and it will make some calculation. A user with a small knowledge in R could change these functions and add new calculation as needed. And with all this, we are generating time series, and I'm going to show you today this little interface that allows you to explore the different time series that are present in Pandem-Source. So here we have an interface with some filters. As you can see, there are many filters corresponding to all of the variables that could categorize data, and some buttons and options we will check later. So the idea is that this interface is flexible. So as you can see, we can explore 74,000 time series in this interface, and they are separated by families. So these different families that were built based on end user requirement gatherings with our partners in Pandem-2 consortium. So let's start with cases. So now you see the number of available time series is reduced. We still have a bit of time series before we can draw something into the screen. And we have several sources that are providing data about cases. In this case, we can see COVID-19 Data Hub, ECDC Atlas, InfluenzaNet. Let's check by example what data is present in InfluenzaNet, and as I said, is a participatory surveillance program which is part of the Pandem-2 project. Now we have reduced to 28 time series, and we can see the indicators. In this case, we have incidence and participant declaring symptoms. Let's check participant declaring symptoms, but we could choose several. We still have 14 time series, and this is basically different countries, but also different pathogens. So let's focus on, let's say, influenza or COVID. And now I have 7 time series, and if I visualize, I can check the evolution of the participants declaring symptoms for COVID-19 in last year. We can check here the evolution of the figures, so the countries which have more participant declaring symptoms are Netherlands and then Denmark. You can check the values. And I would like to request you to check what we see here in the right. Pandem-Source is giving you information about the data that is being displayed. The source, InfluenzaNet, the data quality, which is a cohort, source description, reported by, indicator that is being displayed, the description of the indicator, the unit, and other information as different geolocations that are shown, the source, the period type, which is ISO-week in this case. Let's explore what else we can see here. By example, let's focus into Netherlands data. So I'm going to here in Geo, I'm going to choose Netherlands, and I'm going to add more data from Netherlands, and am I also going to add data from COVID-19 Data Hub. So we're going to check here in indicators, confirmed cases, and participant declaring symptoms. And we have 2 time series, so we can visualize them. And of course, by doing nothing, the scales of the indicators are very different. So we have this option for normalizing data, which means that each time series will be scaled from 0 to 1, and here you can see the different evolution of each time series, and you could try to evaluate which one is having a peak. And it seems that effectively participatory surveillance may have may be anticipating a little bit the beginning of the peak of number of cases, at least in the case of Netherlands. Let's see what other kind of information. You could also compare it in logarithmic scale. You also have this possibility. Okay, so let's try to see other kind of data we can see in Pandem-Source. Let's just clear all the filters, and I'm going to still focus on cases, maybe on COVID-19 Data Hub. Indicator, let's check the RT number, which is calculated by Pandem-Source. And here, let's see that we're going to compare the RT from different countries. By example, France, Spain, and the United Kingdom. I have 3 time series and I can visualize them. And so here we can see the evolution of this metric. But as I said, COVID-19 Data Hub also has the possibility also provide data at more fine-grained level. So we could focus into, by example, French regions, and so in this case we could choose to display all of the regions that has France as a parent, and I have 14 French regions. This is NUTS 1, so we will be displaying data at NUTS 1, and we could see the RT number for each one of the French regions. So just wait a little bit, and here we are. And well, this is a Shiny app, so it has some nice features. You could use, by example, to focus into a particular scale you're interested on. So you can see here that course has a higher RT from the last year, was clearly the case for course. But if not, all of the regions follow a similar evolution for RT, with some difference. And here you can play with the time scale. Last 6 months, last 3 months, last month, and you can see that regions for ultra-peripheral French have a different evolution from the rest of France. Or you can also see the entire evolution from all the period. Let's focus on Ile-de-France, which is the region from Paris, and so we are going to check all of the NUTS 2 that are children from Ile-de-France. We have 8 time series. And here we can see the evolution of all of these departments, and you could go still until NUTS 3. So you could still go to a more fine-grained level. Okay, so we could also add another indicator here. Let's say confirmed cases and or incidence, but in this time I'm going to focus into Paris. A free time series, so I can visualize them. And all the time is the same logic. Here I have number of confirmed cases, incidence, and RT. Again, if you want to compare different indicators in different scales, either you can normalize time series, or you can use a logarithmic scale to compare them. So, I think we have seen enough things about cases. I'm going to just clear the filters and try to test something different. By example, information about patients. And here we have data from COVID-19 Data Hub, but also data that was shared from some of our partners. Okay, number of hospitalized patients. And so we can see at country level, and we have 18 time series. And as you can see now, this new variable appears, which is age group, because we have detailed information by age group. So we are going to visualize different. Here we are seeing the number of hospitalized patients in Netherlands by age group. And as you can see, yeah, the cases which are more represented are this one. And they follow a very similar pattern in terms of number of hospitalized patients. Okay, so what else we have to show today? Let's see information about vaccination. We could compare the vaccination progress from different countries, or let's take data from the COVID-19 data hub, and we could compare at geo level, at country level, the 15 countries that we are extracting from COVID-19 data hub. It's in logarithmic scale, so once it appears, we could change it to standard scale. You can see the evolution of the figures here, and we have two. If you can check, we have two indicators here. We are showing all of the available indicators. At least one dose vaccinated, dose injected, and people fully vaccinated. So probably I'm going to make a choice here and reduce to people fully vaccinated. And you can compare here different countries and the evolution of data from different countries. Deutschland has this reporting, weekly reporting with corrections. We still have to manage to see what is going on with Deutschland. Probably it's maybe something to fix here into the import data. Okay. We have seen vaccination cases. Let's see something different. Let's check information we have about a lab, which is basically sequencing data. As we add labs, you can see that a new filter appears, which is the variant. And so here we have data about in which source, in ECDC. This is data provided by ECDC, geo level by country, and so we have data from different countries. And let's check some variants. Let's check the evolution of the Omicron variant. Omicron. I have a 27 time series, and let's see how it goes. Maybe there is something else to clean. Okay, I don't know what country is that. Something. But well, let's see what we have here. So here we have the evolution of the Omicron variant, and we can see that Ostrich is the country with more sequenced samples, which is not necessarily the country with most cases, because not all of the countries sequence in the same way. But if we want to compare Ostrich, Denmark, Ostrich, Deutschland, Denmark, and France, we could use this normalized view countries. Ostrich, France, we said Denmark and Deutschland. Denmark and Denmark. Go. Yes, and now by normalizing we can see that the peak of Omicron arrived first in France, then in Ostrich, and then in Deutschland, and finally in Denmark. As you can see, we could calculate many more indicators, and actually Pandem-Source is in beta status, which means that you can test it, we can get feedback from you, and we can include more indicators. Okay, and maybe the last thing I would like to show you today is something coming from different kind of data, which is population study. We have data from Medicis and Twitter. So let's check Medicis. We have 18,000 time series in Medicis. So Medicis is a news aggregator produced by the European Union, and it focuses on health data, on health news, and we have just one indicator, which is the number of articles, and we identify the mention of cities or countries or regions inside, and so we try to produce time series for the news mentioning different places. So let's focus at country level. We still have 600 time series, and that is because we use natural language processing algorithms to evaluate the nature of these articles. So we have different pathogens. Let's focus on COVID-19. Also, by using keywords, we can define topics like lockdown, mask, test, etc. Let's get them all first. And we still have 195 time series, and this is because we have all these algorithms. So we have 3 algorithms so far. One algorithm for analysis attention, which emotion analysis, which is classifying algorithms in different emotions. We have sentiment analysis and suggestion analysis, whether an article is or a tweet could contain a suggestion or not. So if we focus on, for example, sentiment analysis, emotion analysis, we are going to select different emotions provided by the algorithm. Okay, and we're going to maybe choose just all of the countries. So here in geo, all of the countries. Yes, and now we have 6 time series we can visualize. So Medicis is providing 1 month of history. So we have been collecting that through maybe we have a little bit more than 1 month of data. And here you can see that related to COVID, most of the articles contains an anger emotion, followed closely by joy, fear, a little bit of sadness, and not much surprise or love. And what is interesting is that the number of articles, the global interest is decreasing on COVID, and also I have the impression that the articles including joy the participation of joy is slowly increasing and going over fear. I hope that's good news in the horizon. In this demonstration, I show you Pandem-Source, and I try to show you some of the different time series we have, explore them, and try to explain you what are the potential of this tool. And as I said, this tool is currently is a beta, so we're still developing, including more sources, more indicators, and we really expect that it will make a difference for pandemic managers. Thank you very much for listening, and see you very soon. Bye from the Pandem Consortium.